So today we're going to continue our work with square roots, but we're going to look at square roots that aren't those nice perfect squares that end in a number all of the time. And we can approximate square roots by using perfect squares. But first we have to know the difference in our number system. So a rational number is a number that can be written as the ratio of two integers. So if you can write it as a fraction, it's rational. An irrational number cannot be written as a fraction in any way. And numbers that are irrational in our number system, the square root of any whole number, that's not a perfect square, the cube root of any integer, that is not a perfect cube, and a decimal that doesn't terminate or repeat, like pi. So rational numbers and irrational numbers together form the set of real numbers, and then you wrote this chart down. Irrational numbers are easy. They're over here. They're things like pi or square roots or cube roots of numbers that don't end and don't repeat. This side is a little bit trickier for you to read. It's a type of Venn diagram or organizational system, and we talked about that. Say you were given the number 12. 12 would be in this natural circle, but 12 has four names. It's a natural number, a whole number, an integer, and a rational number. That whatever its innermost circle name is, it's also everything outside. But if I get negative 12, it's only an integer and a rational number. You can't go back in. It would not be a whole number or a natural number. So you work from the inside out. So when they give you a number that they're asking you to classify it, put it in its smallest circle, and then once you've placed it, now you can name everything. Start with that name and work your way out. So here's an example of classifying. When you see square roots, don't assume that they are all irrational, because not all square roots are irrational. The square root of 16 is 4, which is a natural number. So I know they didn't give you any of those examples over here, which is a shame, but calculate the square root first, and if it doesn't fit the criteria for rational or any of the other categories, it's irrational. This number is rational because it's a repeating decimal, and that's all it is. It's rational. I couldn't fit it in any of these smaller circles because those are all whole numbers. The square root of 9, that's 3, and then it's negative 3. So because I have to make sure to put the negative back on, it starts in this integer bubble, and then it bumps out to rational. So integer and rational. Some of you seeing 72 over 4, you would immediately just said rational and stop. You've got to simplify. See if you can simplify. 72 over 4 actually equals 18. So it's all 4, natural, whole, integer, and rational. And pi is in our irrational circle, and it's irrational. Then you worked on these. This one's irrational for not because it doesn't terminate, because 1/3 is a decimal that never ends, but it's still rational. It's irrational because it doesn't repeat. Like, I know it's adding a 2 each time, but that's not a repeating decimal. That's a pattern, but not a repeating decimal. 2, well, the square root of 196 is 14, because I tried it, and then the negative is negative. So it's an integer and a rational number. And they told us if you see cube root and this number is not a perfect cube, it's automatically irrational. The first cube root that would be rational, or even an integer, is 8, because the cube root of 8 is 2. The next one, I see a lot of people just using a calculator, but on standardized testing, they're not going to give you a calculator when they ask you to approximate or estimate with square roots. So the square root of 71, what they're asking you to do is to pick its closest perfect square. So you have the square root of 64, which is 8, and the square root of 81, which is 9. So you have 64 and 81. You need to pick which one it's closer to. Well, it's closer to 71 is closest to 64, so it's approximately 8. The idea of the 10th, though, is they want you to make this table. I don't really see the value in this, because if you're going to do this, then you should have a calculator available to you. So to the nearest 10th, use a calculator, and then from there you can check your whole number answer. I won't know if you're trying to do this in your head like you're supposed to for the nearest whole number, but try. You're only just cheating yourself if you don't. So then you did these. The square root of 8 is closest to the square root of 9, which is 3, and then we used a calculator for this. The square root of 13 is closest to 16, or the square root of 16, so negative 4. We used a calculator for this. The square root of 24 is closest to 25, which is 5. Bring the negative down, used a calculator. The square root of 110 is closest to 100, which is 10, and then we used a calculator for the tenths place. Please, please, please try to use what you know about perfect squares to estimate the whole number integer. And you can use this very same knowledge to compare two rational numbers or even irrational numbers and say which one is greater. Well, the square root of 5 is closest to the square root of 4, which is 2, which means it's going to be on the lower end of 2 because it's really close to the square root of 4. 2 2/3 is on the higher end of the 2 because 2/3 is almost a full fraction. 2 is really close to 3. I mean, some of you might know that it's 6 repeating, but if you didn't, you can use that knowledge, and that's how you know that 2 2/3 is greater than the square root of 5. And we did these ones, and so 4 1/5 is really close to 4, and the square root of 23 is really close to the square root of 25, which is 5. So we said 4 1/5 is close to 4 because it says explain. Square root of 23 is almost the square root of 25, which is 5, so the square root of 23 is greater. This one should have been obvious for most of you because the other one is negative. If we have one positive, one negative, the positive number is always going to be bigger. This one, when you see two of the same thing, and I talked about over here, square root of 5 or 5, you automatically know when they're both positive that 5 is going to be the bigger one because the square root of 5, it has to be smaller than 5. When it's two negatives, you know that this number is going to be smaller in terms of size. Like it's going to be less than the value of 2. However, the smaller the number, when you're in negatives, the greater the value because it's closer to 0. So when you see two negatives, smaller is greater. Two positives, bigger is greater. And then you can use this information to estimate, you know, the radius or the diameter or whatever it is that they're asking you to find, and they'll give you the formula. So they plugged in 51, they got 17. 17 is close to 16, so it's approximately 4. This is the piece that a lot of you will miss out on, the word estimate, and you try to give an exact answer, which becomes difficult because these numbers aren't meant to be exact. The whole lesson's called approximating, so we're really not looking for exact today. And then we did this one, and 64 divided by 3, well, that's like 21 and 0.3 or 21 and 1/3, and we said 21 is close to 25, so approximately 5. So that's approximating square roots.